Today, we're not just talking about code. We are building the mental roadmap that really separates a good developer from a truly senior engineer. We're going to break down the key concepts that will help you nail that next interview and, just level up your entire career.
All right, let's just dive right in. Picture this. You're in that big interview. It's for a senior role. Things are going well, you're feeling confident, and then they drop this question on you, a huge open-ended system design problem. Your heart kind of sinks a little, right? Your mind starts racing. Should I talk about React? Maybe Redux? Or that cool new charting library I saw? But it feels like a trick question, doesn't it? Because they're not really testing what you know. They're testing how you think.
And here's the secret. The best answer doesn't start with a tool or a library. It starts with a strategy. The interviewer wants to see that you have a mental framework for handling complexity, and that's exactly what we're going to build together, right now.
This right here, this is the foundational shift, a senior engineering mindset. It's about structuring your thinking before you even think about structuring your code. It's about building a solid mental model that's going to guide every single decision you make.
I mean, think about it. Seniority isn't some trivia contest about who's memorized the most library APIs. It's about showing that you have a reliable, a repeatable process for making really smart technical decisions, especially when you're under pressure.
So, where do we start with this framework? It all begins with the absolute foundation of any modern web app, mastering state architecture. Get this part right and everything else just gets so much easier. But if you get it wrong, well, you're going to be fighting bugs forever. First up, we've got to classify our data. The first bucket is server state. This is anything that lives on a back end somewhere. Think user data, product lists, analytics. You get the idea. The key things to remember, you have to fetch it, which is async. You probably want to cache it. And most importantly, it can become stale. It can get out of date.
Now, on the flip side, we have client state. This is all about the UI's immediate memory. Is that little modal window open or closed? What's the user typed into the search bar? This stuff is all happening right there on the user's machine. It's synchronous, and it just, poof, disappears when they refresh the page.
And finally, we have the category that causes the most headaches, the place where so many bugs are born, derived state. This isn't data you're fetching, and it isn't something the user is setting directly. It is a calculation. A filtered list of products, for example, is derived from the full product list and whatever the current filter is. And that leads us to the single most important rule in all of state management. Seriously, if you take away just one thing today, please let it be this. Burn it into your brain. If you can calculate a value from your other state, do not, ever, ever store it as its own piece of state. And this slide just lays it out perfectly. On the left, you've got the anti-pattern, the danger zone. When you store that derived value, you've suddenly created two sources of truth. They're going to fall out of sync. It's a recipe for disaster. But on the right, look at that, the correct pattern, one source of truth. You just compute the result when you need it. It can never be out of date. It's so much simpler. Okay, so we've got our state sorted into buckets. Server, client, derived. Check. But that's only half the story. Now we have to talk about the shape of that state, especially our server state, and that's where this key pattern comes in, normalization. So what is normalization? Well, it's basically taking messy, nested data and flattening it out. So instead of a big array of users you have to search through, you make an object where the keys are the user IDs. And the benefits here are just massive. You get instant lookups by ID, no more data duplication, and updating a single user, it's trivial. You change it in one spot, and your entire app knows about it.
Now, you might be thinking, okay, this state stuff is cool for organizing code, but what does it have to do with making my app feel fast? Well, it turns out this deep focus on state architecture is the absolute key to unlocking high performance in an app. Let's dig into how.
Yeah, let's just ask that question directly. How on earth does organizing our data objects better actually make the UI feel snappier? What's the real connection between a nice, normalized state and that buttery smooth 60 frames per second experience we're all chasing? Well, the answer is all about how React actually works under the hood. Anytime state or props change, React does this little three-step dance. First, it renders. It calls your component to get a blueprint of what the UI should look like. Then it diffs. It compares that new blueprint to the old one. And finally, it commits. It updates only the tiny little pieces of the screen that actually changed. And here's the kicker. That render step can be expensive. Think of it like a little performance tax. If your state is a mess, you'll end up causing dozens of components to re-render when maybe only one of them actually needed to. This, right here, is the #1 performance killer in most React apps. Good state architecture makes sure your updates are surgical, precise, triggering the absolute minimum number of re-renders.
All right, we've laid all the groundwork. We've got all the building blocks. We understand state classification, we get normalization, and we see the link to performance. Now, let's put it all together and assemble that confident, structured, senior-level answer. So, here we are again, back in the interview hot seat. But this time is different, isn't it? There's no panic. We're ready, we have our mental framework, and we're ready to deploy it.
So instead of just blurting out a library name, you lead with strategy. You say, my approach would start with the state architecture. Boom. You classify the state, you explain how you'd normalize the data for lightning-fast access. You talk about using memoized selectors to efficiently calculate derived values. And for that data-heavy part, you mention UI virtualization, only rendering the rows the user can actually see.
Do you see the difference? It is night and day. This is an incredibly confident, structured response. It shows you understand the real challenges, not just the names of some tools. You're not just answering the question, you are leading the entire technical conversation. That's a senior-level answer.
So we've gone through the whole framework. But look, just watching me talk about it isn't enough. The real question is, how do you internalize this stuff? How do you make it so it becomes your automatic, default way of thinking?
You do it with this simple, powerful loop. First, you learn the concept, which is what we did today. Then, and this is my favorite part, you have to explain it. Try to teach it to someone else. If you can't explain it simply, you don't really get it yet. Then you apply it in a real coding task, and finally, you refine your understanding. You just keep running that loop, and knowledge turns into instinct.
So I'm going to leave you with a call to action, some homework. Think about the app you work on every day. I want you to find one component. You know the one I'm talking about, the one that's complicated, or slow, or always has bugs. Now look at it through this new lens we've built. How's its state structured? Is there derived state being stored that shouldn't be? Could you normalize some of that data? Your path to mastery begins right there today.